The Open Systems Interconnection Model is one of the most important tools in networking. It breaks down the complex process of communication between devices into 7 clear layers, each with its own job. If you've ever wondered how your email gets sent or how streaming videos load, understanding this model is like looking under the hood of a car. It shows you exactly how all the parts work together to make the internet run smoothly. Let's go step by step, layer by layer. At the foundation, we have the physical layer. This layer deals with the actual hardware, the cables, switches, and even the Wi-Fi signals that carry data. Imagine it as the road system that allows vehicles to move between cities. If the roads are broken or poorly maintained, traffic won't flow. In networking, if your cable is damaged, your connection won't work. This layer also handles things like voltage levels and how bits of data are physically transmitted. In our class, we spend time crimping Ethernet cables, ensuring the connections are solid and data flows without interruption. Without a reliable physical layer, no amount of fancy software will save your network. The next layer is the data link layer. This layer makes sure the data gets to the right place on the local network. It's like the street address on a package. It tells the system where the data needs to go next. Every device has a unique hardware address called a MAC address. The data link layer uses this to ensure the information reaches the right device. For example, when you connect to a coffee shop's Wi-Fi, this layer keeps your laptop's data separate from someone else's phone. In our class, we explore VLANs, which are like creating separate neighborhoods within the same network. VLANs allow you to organize and secure your devices, ensuring that traffic stays where it's supposed to be. Now we move to the network layer. This is where routing happens. While the data link layer works within a local network, the network layer decides how data moves between networks. It uses IP addresses to figure out the best path, much like how GPS calculates the quickest route for a road trip. Routers operate at this layer, and they're responsible for forwarding data between different networks. In class, we configure routers to handle tasks like NAT, which allows multiple devices in a home or office to share a single public IP address. This layer also introduces concepts like subnetting, which helps you organize large networks into smaller, more manageable sections. Above that is the transport layer, which ensures that the data you send actually arrives. It's like sending a package with a tracking number. This layer breaks data into smaller chunks, called segments, and sends them out. If something goes wrong, like a lost segment, the transport layer ensures it's resent. The 2 main protocols here are TCP and UDP. TCP is like certified mail. It ensures delivery but takes a little longer. UDP is faster but doesn't guarantee every piece will arrive. In class, we use tools like Wireshark to observe how these protocols manage data flow. Understanding the transport layer is essential for troubleshooting issues like slow connections or unreliable streaming. The session layer is where conversations between devices are managed. Think of it like a moderator at a debate. This layer starts the conversation, keeps track of who's speaking, and makes sure it ends cleanly. It's especially important for applications that need a constant connection, like video calls or online gaming. In our class, we simulate this by setting up multiple Wi-Fi networks and testing how devices communicate across them. This layer ensures devices stay synchronized and don't accidentally drop the connection. Next is the presentation layer, which acts as a translator. Data comes in all shapes and sizes, and this layer makes sure it's in a format the receiving device can understand. It also handles encryption, which is like sealing a letter in an envelope so no one can read it in transit. For example, when you see a padlock icon in your browser, it means the presentation layer is encrypting the data. In class, we use tools to visualize encrypted and unencrypted traffic, showing how this layer protects sensitive information like passwords and credit card numbers. Finally, we reach the application layer. This is the layer you interact with directly. It's your email app, your browser, or your video streaming service. This layer doesn't handle the technical details. It focuses on making the experience easy and useful for you. When you type a website address into your browser, the application layer sends that request down through the other layers, and they do the heavy lifting to bring the website back to you. In class, we explore how DNS, the domain name system, works at this layer. DNS acts like a phone book, translating easy-to-remember names like google.com into the IP addresses computers need to find each other. Understanding the open systems interconnection model isn't just about memorizing the layers. It's about seeing how they work together to make networking possible. In our class, we bring these concepts to life through hands-on activities. From crimping cables to configuring VLANs and analyzing traffic with Wireshark, we show you how each layer fits into the bigger picture. Once you understand this model, you'll be able to troubleshoot issues, design better networks, and even explain these concepts to others. This model is the blueprint for how all devices communicate. Whether you're a beginner or a seasoned IT professional, knowing these 7 layers gives you the tools to understand and improve any network. Thanks for watching, and I'll see you in the next session.